My panel cart is flexible, mobile, and can deliver over 1,000 watts of pure solar power. And on a sunny day, it has no problem meeting my daily energy needs, along with recharging the batteries on my power cart, making this a really robust solar generator. As I stated earlier, in order to maximize my panel's effectiveness, they are mounted on a mobile cart. To help protect the panels from the elements and set it up for the next day, I park the solar cart behind my house at the end of each day. As you can see, the panels face east early in the morning, and I have a dozen or so trees that I have to maneuver in between if I want to maximize the panel's efficiency. I'm going to show you the main areas where I position my cart throughout the day to maximize the panel's efficiency. The trees are on the southeast side of my property, and as you can see, the shadows move across my backyard until late afternoon. I am able to move the panels around with a couple of inches of snow on the ground, but when it got up to 6 inches, I had to use my snow blower to clear paths for the cart. This is generally the final position for the day, and once the sun goes down, I move the panels back behind my house and set the angle for the early morning sunrise. There is some effort to this plan, but when I need to, I can maximize the panel's efficiencies. Some days, I just leave the panels facing south. Okay, there's about 45 degrees, and that's about optimum. Let's go to 30. That's 30 degrees. Go to 20. Let's go back to 45. And let's go to 70. What you're hearing is me locking in the angle. Yeah. I knew that direction and angle would have some effect on the panel's ability to harvest energy, but the question was how much effect. So I went ahead and conducted this simple test. What you are looking at is an aerial view of my backyard. I recorded and synchronized my Charge Controllers app to the movements of the panel cart. To start, the panel cart is facing south and set to 30-degree angle. South and 30 degrees of angle is how everyone in my area sets their fixed panels. During the test, I will adjust the direction and the angle of the panels so that they are directly facing the sun. Notice as I approach the panel cart, the panels are yielding about 195, 196 watts of power. I'm going to call this one 196. As I rotate the panels toward the sun, the wattage increases to right around 300 watts. Then, when I adjust the angle, the wattage continues to increase to just a little over 400 watts. Now I'm going to walk in front of the panels, and you can see just how much of effect the shadows has on the panel's ability to yield power. Now that everything is stabilized, I would say that the amount of energy coming into the system averages around 405 watts of power. And if we look at the baseline of 196, there is over a 200 watt difference. It definitely appears that the direction and angle both have an effect on the panel's ability to harvest energy early in the morning. Now let's look at it a little later in the morning. As you can see, the sun still has not reached its highest point in the sky. I'm going to call this baseline 780 watts. As you can see, as I'm moving the panels are positioned between the tree shadows that's cast to the southwest and to the northeast. I'm going to call this one around 925 watts or 145 watt difference. Once again, it appears that direction and angle have an effect on the panel's ability to harvest energy. According to my phone's app called Magic Hour, the sun is now directly over my position relative to my latitude and longitude. Once again, facing south and the angle set at 30 degrees, I'm going to call this baseline 896 watts. Notice I make very little change in direction. The majority of the change is in the angle. I went from 30 degrees to 47 degrees. As you can see, all of the shadow is basically to the north. There is a little bit of shadow along the base of my house, but that's due to that 1 foot overhang from my roof. I'm going to call this at 927 watts, which is 31 watt difference between the baseline. This shows that direction has a minimal effect at midday. The real effect would come from the angle if my panels were fixed at 30 degrees. This is my final test for the day. The sun is right around 16 degrees above the horizon and it is now overcast, but you can see a faint shadow as I am walking up to the cart. I'm going to call this baseline right around 101 watts. Notice even though it is overcast, the panels are still capable of generating power. On this test, I'm going to do something a little different. I'm going to freeze frame right here before I change the angle of the panels. Notice that just changing the direction, we have gone from 101 watts to 195 watts. Just changing the direction has almost doubled the output of the panels. Notice now I'm right around 228, 227 watts. And as I walk in front of the panels, once again, it shows the decrease in the power of the panel's capability. At this time of day, even with an overcast sky, the panels are capable of producing 228 watts of power, or an increase of 127 watts from a fixed position. Once again showing that direction and angle have an effect on the panel's ability to produce power. Now I'm going to take a couple of minutes and summarize the test. The first test had an increase of 209 watts. So during the 2 hours between the first and the second test, potentially there could have been an additional 400 watt hours added to my system. The second test had an increase of 145 watts. During the 2 hours between the second and the third test, there was a potential for adding another 290 watt hours, now bringing my system up to an additional 690 watt hours. The third test only had an increase of 31 watts because the sun was virtually due south and the angle was only a couple degrees off. The final test had an increase of 127 watts, so for the 4 hours between the third and the final test, there was the potential of adding another 225 watt hours. That means that from 9 a.m. to 6:30 p.m., having an adjustable system could potentially have added an additional 1,000 watt hours to my battery bank, showing that direction and angle both have an effect on the panel's ability to generate power.